Cool. So I guess we are back. Okay. So today we'll start looking into graphs. Okay. So probably there are a few terminologies which I have to cover. Okay. And if time permits, then we will cover what is DFS in graph. Okay. And if we do have time, I can take questions. Otherwise, at least till DFS, maybe we can try to complete. Okay. And maybe we can take up a simple question and solve it. Okay. Now, again, since it's a new topic, I just wanted to get information from you guys, whatever you know. So, if someone is interested, you can come ahead and tell me what's graph or whatever you know in graphs. Anyone?
N nodes and n minus 1 edges, but with a cycle.
Yeah, wrong definition. Totally wrong definition.
Definition in the sense like when it comes to trees and this opposite, like only cycle is different.
You said n minus one edges, right? Who said there will be n minus one edges?
Okay, okay, yeah.
There is no n minus one. Deva, you want to give it a try? I guess you have seen something in graphs.
I mean, like it's the same. You won't be having n minus one edges. You can have any number of edges. So it's be like the in direction and out direction for a particular node.
Mm-hmm. Okay, Sas, Manan, do you guys want to contribute anything in this?
Yeah, a number of nodes
Okay.
and direction
Mm-hmm.
in given.
Okay. What about Manan?
And it's all about
Direction
the
will be
relationships.
given,
If you
cycle.
have any relationship between any two of the things, then we'll be like using graphs.
Oh, nice. Okay, so whatever the point, I mean, he mentioned it's kind of like very much simple, but to put it, you know, why graphs are very powerful data structures. It is used in many real life applications. Okay, and like if you get time, probably you can see that Facebook has started his database using graphs database. I mean, it's like it's stored. There are two kind of things they stored. Okay, one is node, and like there are two things, right? One is node and one are edges, right? Okay, we'll talk about that, but most of the things in the initial days of Facebook, they have represented using graphs. That when two people are connecting, they have made an edge connection between two people. And when someone is creating new account, or someone is commenting on something or doing some event, that is they are represented as node. And among whom it's happening, they have represented it kinds of edge. Okay, and there are many other applications also, like in real life also, maybe like network transmission, and there are many. Okay, but yeah, I mean, we are not going to talk about all that. So let's start with the basic definition. Okay, what's a graph? Okay, so a graph is kind of a structure where you generally have two kind of things. Okay, one is nodes, okay, and one is edges, right? Now, so in mathematically, we represent something as graph equals to set of v comma e, which is some v vertices and e edges. Okay, so just an example. This is a graph. Okay, this is a graph. Now a graph can have n nodes and m edges, and the difference between a graph and a tree is like tree is a subset of a graph. Okay, so graph is like super and tree is a subset of it, with there are some properties which we have already studied, that there are n nodes and minus one edges, but here there can be like m edges. Okay, there can be m edges, and there won't be any unique path between two nodes. Okay, let's say if I have to reach from A to C, okay, I can go like this and reach, I can go like this and even I can reach, right? So there can be multiple paths to reach to a particular node. Okay, I mean, there are like different ways to go and reach over to a particular cell. Okay, so there is, and there is one more thing, that there there can exist a cycle in a graph. And what's a cycle? Cycle is simply that if you start from any node, and if you're again come back to the same place, it's a cycle. Let's say if I started from 1, okay, I can go to 2. If I can from 2, I can go to 3, and if I from 3, I reach back to 1, right? So this is nothing, this is known as cycle. Okay, now what are nodes? Nodes are this, that these are the like some information or some kind of event you represent as a node. Okay, an edge is something, a relation between any two nodes. Okay, so is the definition clear of nodes and edges? I mean, we shouldn't concern much, but yeah, just to let you know. So is it clear, nodes and edges?
Yeah.
Okay.
There is no directions in graph, na? Ki there is a
No,
direction.
we will talk many other things.
Oh,
Okay, not only direction, we will talk all of them today. Next.
okay.
So like next, let's talk about directions. Okay, so in graphs there are two kind of uh, two categories which you can probably speak for. Okay, one is undirected. Okay, one is undirected, second is directed. Okay, now what's an undirected? So let's say you have some graph. Okay, this is an undirected graph. Now why it's an undirected graph? Because you don't know whether A is actually connected to B or B is actually connected to A, right? I mean, there is no kind of direction given. That means A and B both are related with each other. That is, you can go from A to B, also you can go from B to A. Okay, so this is an undirected, that is there is no direction given between the edges. Okay, but coming to directed, it's kind of opposite to that. That is, you have a graph, okay, but you have directions now. Okay, so something like this. Now you can probably think of A A has been sent a friend request to B, okay, or A is connected with B, C is connected with B, something like that. Okay, so a directed graph is something that which has a direction associated. Now in this case, you can go from A to B, but not from B to A, because there is no edge like this. Okay, but if you have an edge, you can go from A to B and come back from B to A. But in the case whatever we have drawn earlier, what we have seen is like there is an edge from A to B. That is, you can go from A to B, but not from B to A. Okay. Is it clear? Undirected and directed?
Yes.
Okay. So just give the acknowledgement others too. Okay. I just wanted to move.
Yeah.
Yeah.
Yeah, got it, bro.
Okay. Next. So again, among them, among undirected and directed, again, like each one of them can have two categories. Okay. So first category being unweighted, second category being weighted. Okay, now what are this? So when you have a graph, let's say again, let's draw some random graph. Okay, so whenever you don't have an weight, what do you mean by weight? Weight means some number associated among among two nodes. I mean, if there is some information represented using uh, in an edge, that is weighted. In this case, you don't have any numbers or some information, right? It's just a normal graph, correct? But in the case of weighted, you have something like this, that for each of them, let's say if you're going from A to B, it will cost you 3 rupees. Okay, let's say if you go from B to C, it will cost you 10 rupees. Let's say if you go from A to D, it will cost you 20. So whenever an edge have some kind of cost, you kind of associate that as a weighted graph. Okay, and whenever you don't have some any weights or any numbers between in an edge, that is known as unweighted graph. Okay, so in general, we think it as a single unit, one unit. Okay, unless they are given, I mean, you can consider it one or zero. I mean, it's better you can consider. Sometimes you should consider one also, sometimes zero. Okay, so now, but I'm just not writing because unweighted is something that which don't have any weight on an edge. Okay, is it clear? Unweighted and weighted.
Yeah.
Yes, bro. Yes.
Okay, next, let's talk about something as degree. Okay, degree of a graph, degree in a graph. Now again, so we are talking about different variations, right? So let's say you have a undirected graph. Okay, you have an undirected graph, and again there can be one more graph which is directed, right? Something like this. No. So degree is nothing but, in an undirected graph, a degree is nothing but how many edges which are associated with a node. Okay, how many edges are associated with a node. So for this node, the degree is 1 because there is only one edge. Okay, for this node, the degree is 3. For this node, the degree is how much?
2.
1.
1, right? Why 2, Deva? There is only one edge, no?
Okay, sorry. I
Yeah.
thought there's a connection between 1 and 2. Sorry.
So there, for this
Wow.
the degree is 2. For this the degree is 1. Okay. So degree is nothing but, in an undirected graph, is how many edges it is been associated with. Okay. Simple.
Hi.
But when it comes to directed graph, right, you have two terminologies. One is in degree and one is out degree. Okay. One is in degree. The second is out degree. Okay. What do you mean by in degree? It's again, the meaning is clear from the name itself. The number of edges which are coming, which are pointing to that node, is in degree. The number of edges which are going outside is out degree. Okay. So let's take for this, how many edges are coming inside to this, pointing to this node. You can see only one, right? So for this node,
Yes.
in degree is 1. For this node, you can see there are two edges which are going outside, so that out degree is 2. Okay, clear?
Yeah.
Okay.
Yes, bro.
Yes.
Okay, so you got the clarity, right? In degree, out degree. Okay, now
Yeah.
quick question to all of you. Okay, so like we will represent from 0 to n minus 1. Okay, I mean node numbers are 0, 1, 2, 3, 4. Okay, now what I wrote is, you need to find the summation of, that is summation of degree of all the nodes. Is it clear? So what you need to find is sum of degrees of all the nodes. Now, what will be the answer in terms of V, E, or whatever?
A number of edges, right?
No.
Like in the adjacent list, we'll be taking some of that one. Like size of that and some.
Don't go to adjacency, Sam. Okay.
Okay. Okay.
The question is sum of degree of all nodes.
5,
हैं? कॉमा वॉमा कहाँ से आ गया? ये तो वैल्यू होना चाहिए.
7 है ना वैल्यू?
नहीं, actually what's the answer? The answer is 1 plus 3 plus 1 plus 2 plus 1, right? 8. Can you see? It has 1, it has 3,
हाँ.
it has 1, 2. So answer should be 8. Now how will you represent in terms of V, comma, E? I mean, you saw, right, the definition? We represented as. So Sahas said E, but it is not E. It is something else. And what's that? But you are in the correct direction, Sahas. Just think of something.
Weight into.
No, there is no weight concept. 2 into E, right? Why 2 into E? Each edge is nothing but associated with two nodes, right?
Okay.
Now
Yeah.
this edge, there is 1, this is 2, this is 3, this is 4, and each edge will be counted twice because of two nodes, correct? So 2 into E, that is 8, and this 8 is same, right? Got it?
Yeah.
Yeah.
Manoj?
Yes.
Yes.
Yeah. हाँ.
Okay, chalo, ठीक है. Next. So degrees are clear, right? In a directed graph and in a indirected, we have something as in degree, out degree, and there is no concept of in degree, out degree in an undirected graph. Next, next thing probably we can discuss is reachability. Reachability. Reachability means, let's say we have some graph. Okay, let's number them maybe 0, 1, 2, 3, 4, 5, 6. Okay, can you reach from 1 to 6?
No.
No.
No, right? Because you can go from 1 to 3, 2 or 0, but how can you go to 6? You cannot go, right? So reachability is nothing but given two nodes, can you reach from one node to another node? That's all. Okay, this is reachability of a in a graph. Clear? Simple. I mean, can you reach from one node to other node? Now, let's talk about uh, something as maybe, let me think, what can I take more? Okay, let's talk about path also. Let's say you have a graph something like this. Okay, is this a valid path? Valid path means if you go from each from one after the other, can you reach this sequence? Let's say you started from
No,
2.
it's a disjoint.
Yeah, so from 2 you can go to 3. Okay, this is nice. From 3 you can come back to 4. Okay, that's nice. From 4 you can again go to 3. That's good. From 3 again you are going to 2. But from 2 can you go to 5?
No.
We cannot, right? So this is not a valid path. Okay. So path is nothing but a sequence of moves to reach from one node to another. That's all. Clear? Is path clear?
Yes, bro.
Oh. Next. Manan, is it clear?
Yes. Huh.
Sam, I hope you are clear.
Yeah, clear.
Next, we have something as sparse graph and dense graph. Okay. Sparse and dense graph. Now, what's a sparse graph and what's a dense graph? Okay. Now, like, there are different definitions to it. Okay. But we will kind of like derives our own definitions. Okay, I mean it varies from one blog to one blog or one website to another. Okay, so let's say you have a graph. Okay, let's say you have an undirected graph. Question to you guys is, without self loop. Okay, now what do you mean by self loop? Self loop is nothing but a node having an edge towards itself. This is nothing but a self loop. Okay, that is, from that node you are just rotating to that node again and again, again and again. Okay? This is known as self loop. Now, in a graph, let's say you have some nodes. Okay, in this case there are 4. How many edges I can draw? How?
2 into 8.
2 into,
E number of edges, right? I mean, like the number of nodes.
the question is that only, right? Key, how many edges you can draw? So there is no e.
I mean, the number of nodes.
Number of nodes.
So 2 into
2,
4.
3.
Is it 2 into 4, Deva?
Uh, I guess 6, right? Minus 2, probably. It's a bidirected 6.
No, there can be many other connections. I am asking you how many maximum edges you can draw without self loop.
4. I mean, remaining 3 and minus, if from a particular node, you can have 3 nodes, right?
So n minus 3.
I mean, not in minus 3. I mean, अगर एक node से we can connect to 3 nodes, right?
Uh-huh. Yeah. So tell like
So
that. Yeah, we have n nodes. So how you can mathematically represent edges, maximum edges? Anyone want to give it some try? There are
n into n minus
n into.
n minus 1.
Sure.
Probably. Wait a second, I'll count. Yeah,
5 ही है ना?
Sorry.
yeah,
Five
bro.
edges.
My side, yeah.
N into n minus 1, right? So one node can be connected with n minus 1 nodes, right? इसका मतलब if one node is able to connect with n minus 1, all the other nodes can also connect, correct? So n into n minus 1, because with each node you are able to connect to n minus 1 node. So n into n minus 1. Okay, clear? Clear?
Yeah.
Yes,
Okay,
bro.
like
Yeah,
in that
from
case,
my side.
1 to 2 and 2 to 1 we'll be considering as two edges.
Edges.
That's a good question. So it depends, Sam. Okay, so if you're doing like that, okay, then uh, what you said is good, that 1 to 2 and 2 to 1. So these are same, right? Because this is an undirected graph, correct?
Yeah.
So n into n minus 1 fails here. I mean, this is not a correct formula. If you want to say that 1 and 2, matlab if there is an edge 1 to 2 and 2 to 1, so why this is like n into n minus 1 का meaning क्या है? With one node you are trying to connect with n minus 1 nodes, that is from 1 you connected with 2, but again you're saying that from 2 also you need to connect with 1, so which is wrong, correct?
Divided by 2.
Exactly. And this is nothing but, let's not try to kind of buttify this. Okay, it's very easy. There are 4 nodes, right? How many nodes are there? N nodes. In order to make an edge, how many nodes I should choose?
N minus 1. And see, yeah. 2.
Yes.
Correct, right? If I pick any 2 nodes from n nodes, can I say my answer is done? That is n into n minus 1 by 2.
Okay.
Okay. Now, what about this is undirected graph. What about directed graph?
We can't determine that direction.
No, let's say 1 to 2 like this, 2 to 1.
Okay, both.
Yeah,
N into
Then
n
n
minus
n
1.
minus 1, right?
exactly. So that is, you just multiply by 2, 2, 2 goes, and this is the answer. So in an undirected graph, it's NC2, and it in here NC2 into 2. Okay, because like here you have 2 directions now. Now, so coming back to our question, a sparse graph and dense graph, right? So in a graph, you guys just saw that from 0 we have somewhere around n into n minus 1 edges, right? Correct? There can be these many edges, right? Arey, Hana bolo. It's from 0 to n into n minus
Yeah,
1.
yeah.
Yes.
This many.
Yes,
Yeah.
bro.
So let's draw a point. This is something like what? Maybe something, there is some parameter, I don't exactly remember, but all the all the graphs which are having edges greater than root 3n by 2 or something will fall into dense graph. Okay. And all the nodes which are having these many edges will fall into sparse graph. Okay, dense means what? Many, right? Dense means as many as possible. What is sparse? Sparse is like as less as possible. Okay, so there is this limit. I am not exactly remembering this exact midpoint, but there is this some point which actually differentiates sparse and dense graph. Okay, but in our case we can just think of like, the more the edges are, it goes towards dense, the less it goes towards sparse. Okay, clear?
Yeah, yes, bro.
Okay. So I guess it should be something like n into root n, maybe. It might be something, I'm not exactly sure, but yeah, somewhere some limit is there. Okay. Okay. So yeah, that is sparse and dense graph. Okay. Next we have something as connected components. connected components. First question is, how many graphs are there here? Is it 3 or is it 1 or is it 2?
3.
Yeah, so this is one thing, Sas, that there are no there is no 3 graphs. It is one graph only, but it is disconnected. Okay, it is broken into components. And what do you mean by component? Component is from each node you can reach to other nodes. Okay, so this is one component, this is one component, this is one component. Okay, so these are 3
Okay.
components. It's a single graph, it's not a 3 graphs. Okay, it's a single graph, but these are one graph is broken into 3 components. Okay, and what's a component? A component is if you start from any node you can reach to any other node. Clear definition?
Yeah.
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 Okay, okay, this is connected component, but what I have drawn is undirected, right? Correct. So you have
Mm.
something as for directed also, and for directed it is known as strongly connected components, and we will see. I mean, it's an advanced, but again I'm not sure if we have to cover or not. There is some famous algorithm for detecting strongly connected component, which is Kosa-Raju's algorithm. Okay, so what is strongly connected component? Same thing, that uh, like you have a directed graph now. Okay, you have a directed graph kind of. Okay, now the same concept goes that in a directed graph, if you start at any node you should be able to reach any other node. Okay, so this is one strongly connected component, because if can you see that if you start from any node you are able to reach any other node in this. Let's say you started from this node,
Yes.
can
Yes.
I reach here? Yes, I can reach. Can I reach here? Yes, I can reach. If I start from 1, can I reach to 2? Yes. Can I reach to 3? Yes. So in a directed graph, the concept is not about connected component, it's about strongly connected components. And what's a strongly connected component? That is between each pair of nodes you should be able to reach. Okay, this is one mode SCC. Okay, now doing this is very easy, but this requires some other modifications, and one of the famous algorithm can easily help you to find is Kosa-Raju's algorithm. Okay, but yeah, is SCC clear? Strongly connected components.
Yes, bro.
Next,
Yeah, bro.
next we have something as bipartite graph. Okay, bipartite graph, and say you have a graph something like this. What you have to do is, if you have to pick two colors up. Okay, and you have to color the nodes in such a way that adjacent colors should not be same. Okay, so in this case maybe I can color this with something as red, blue, red, uh, blue, red. So can you see it's a bipartite graph because I am able to color this perfectly. Correct? That is, any two adjacent nodes don't not have the same color. Can you guys see this? Just a quick yes if you guys are able
Yeah.
to.
Yes.
Yes, bro.
Mm.
But is this bipartite graph? Let's say I'm trying to color with red. Okay, I have to color with blue. Now this one, which color should I choose? Should I choose red or should I choose blue?
Either of the thing will not.
So any of them is not working, right? So
Yes.
a a graph which has a odd length cycle will never be a bipartite graph. Okay, obviously I will take this question separately, but just to for this definition, remember this point, that if you are able to color the graph with two colors, why bipartite? Because two colors. Okay, such that each of the nodes, which are whatever the adjacent nodes you have, if they are not colored in the same color, it's a bipartite. Otherwise, it's not. Okay. Definition clear?
Yes, bro.
Okay. Others?
Yeah, got it, bro.
Okay. Next we have
Yeah.
something as Eulerian path. Okay. Okay. So what's an Eulerian path? So Eulerian path is something where you have to visit all the edges. You have to visit all the edges exactly once so that all the nodes gets covered. Okay. Now in this case, it's, if you see, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So all the edges you have traveled only once, right? And if you see that uh, uh, all the nodes are also covered, correct? So it's an Eulerian part. But what about this? If I have to cover all the edges exactly once, and if I have to visit all the nodes, can I say this edge will be repeated twice? Because you have to go to 1 to 2, 2 say you will go to 3, from 3 say you will go to 4, from 4 say let's say you went to 5, but you have to visit 6 also, right? What about 6? So you have to come back, there is no other way, right? So from 5 again you will come back, come back, come back, and you will go. So can you see these are the edges which are
Yeah.
repeated
Yes,
multiple
bro.
times? So in that
Yes,
case,
yes.
this is not an Eulerian path. Okay, an Eulerian path is a path where all the edges are visited exactly once and all the node gets covered. Clear definition?
Yes.
Okay. Similarly, we have something as Hamiltonian. Okay, Hamiltonian Hamiltonian path. So Hamiltonian path is nothing but, you have talked about edges, right? So it's about visiting all the nodes exactly once, not all the edges. Now it's all about visiting all the nodes exactly once. Okay. That is, so here, if you visit all the nodes exactly once, you are able to travel to each one of them. Okay. But what about this? In this case, you have to like go here, go here, here, you need to come back, so you are visiting this node two times, right? So this is not a Hamiltonian path. Okay, so Hamiltonian path is a path where you can, if you can visit all the nodes of a graph such that each node is visited exactly once. Okay, just opposite to this one, Eulerian path.
So what's the difference, bro?
I mean, there are algorithms, man. Okay, so if you go to harder problems, then these are categorized. Okay, I just took the definition. Okay, for us now it's out of context for now. Okay, I mean, there are hard problems which will be based on this and this. The difference is like it's on edge, it's on nodes. Although you're thinking that it's on node and it's an edge, but when you go to harder problems, there comes a lot of things. Okay.
okay, okay.
Yeah. Like even I am not good. I mean, I also don't know the algorithms to solve this problem. So yeah. Okay, so these are the some of the definitions of a graph. Okay, I mean, whatever the terminologies I have spoken about, these are the things which are required in our further sessions. Okay, obviously except these two things. Clear?
Yeah.
So
Yeah,
Yes,
bro.
bro.
okay,
Yeah,
Yeah.
clear.
so shall we move on to the next thing, or do you want me to stop, or shall we do DFS? Probably. Good, right? We can cover something today.
We can do DFS today.
Okay.
Yeah.
Yeah. Okay.
Okay. So no. So there are again, we have already discussed this in trees, but again, just to reiterate back. So there are two very famous algorithms, right? And you guys have already known these terms by now, which will help us to travel in a graph and explore all the nodes, do some manipulation or whatever. Okay, so there are these famous techniques DFS and BFS which will help us to explore the graph. Okay, so today what we will look into is something as DFS. Okay, so everyone knows, right, what is DFS? Like going uh, as depth as possible unless new nodes are discovered and you just come back and travel on a new path, right? This all DFS does, right? We have also learned this in a tree, correct?
Yeah.
Okay.
Yeah.
Yeah.
Yeah, but there is only one small thing. I mean, the code remains same, but here
We
there is one
structure.
small thing. The caveat is in a graph. Okay, let's take this graph. Okay, 0, 1, 2, 3, maybe 4, 5, 6. Okay, in a graph there exists a cycle, right? There exists a cycle. I mean, a cycle can exist. So what happens is, if you cannot handle cycle, what will happen is your recursion will go on an infinite loop, right? So that's the problem. Okay, in a tree, since there is a no cycle, we just maintained parent and we are done. But in graph we will maintain something as visited array. Okay, now what is a visited array? Visited array will denote whether you have visited this node or not. Okay, is the visited array definition clear?
Yes, bro.
Yeah,
Yes.
bro.
Okay,
Yeah.
let's start from 0. Okay, so what happens in a DFS, we will start from any arbitrary node and we will start our exploring the graph. Okay, let's say we start with 0. Okay, so 0, as soon as you go into recursion, the first task which you have to do is mark this node as visited. What do you mean by marking? That is, you have explored this node. Okay, so I will go and I will mark it as true, which will indicate that I am already done. Okay, next, from 0 till where you can go to?
One.
Only 1. So okay, I have 1. Now is 1 visited already?
No. No.
No.
So it is for the first time. From 1, where you can go to? You can go to 0, you can go to 2, or you can go to 3. Okay, let's
Yes.
try to go to 0. But I see in my visited array that 0 has already been there. 0 has already been visited. So will I go again?
No.
So,
No.
Obviously no, because if I go, then what's the purpose of keeping? There is no purpose, right? If you go here again, it will come back to 1. Again, it will go back to 0. So recursion will continue. It won't terminate. Okay. So that's the reason this array will help us to keep track of what are the nodes you have visited. Now from 1, I see that 2 is not visited. Okay, we are good. Let's go to 2. Where we are at? We are at 2. From 2, I can go to 1. But will I go to 1? No. Why not? Because 1 has already been marked. Okay. So from 2, where I can go to? I can go to 3. From 3, again I will go to 5. From 5, I will go to 4. Now, can you see from 4, we don't have any further nodes, right? We don't have any further nodes. So what we'll do is we'll come back. I mean, recursion will come back, and it will try to explore from 5 what are the different possibilities. So from 5, since I have already visited 4, next I see 6. 6 is unvisited. Let's go there, visit it. From 6, can we go any further? No, we cannot. So recursion will come back, it will come back, and it again, I mean, if you see, all the nodes have been explored and your recursion is done and you have finally done something. Okay, this is DFS.
okay.
Okay, now, important part. Just now, we discussed one thing, that in a graph, there can be multiple components, right? Is this a two graph or is it one graph?
One graph.
Only one, right? These are two separate components. That's all, right? So let's say we started DFS with 0. Okay, what happens? 0 will be marked as true, correct? 0 will be marked as true. Next, 1 will be marked as true. 2 will be marked as true. 5 will be marked as true. Is it? That's all right. Yes. And didn't you guys understand this?
Yeah, got it, got it.
From 0,
Yeah.
I do a DFS. I'll
Yes, yes.
Yeah.
okay. Now, but what about 4, 3, and 6?
Yeah.
We still did not visit this, right?
Yeah.
So in that case, we have to visit this also, no? So what we will do is
Yeah.
Yes.
in a DFS, okay, I will explain in code, but what we do is we try to do DFS from each one of them, okay? And when we try to do, whenever if it's not visited, okay? So when I started with 0, can I say I can visit all of them at once?
Yes.
Yeah.
Correct. Next, we will iterate on 1. So is 1 visited already? Yes, it is visited. So there is no need to do DFS, right? Because if 1 is visited, then I am sure that someone has already marked. Correct. 2.
Yeah.
2 is also visited. That means already someone has marked. That means already you have already explored. What about 3 now? Is 3 true?
No.
No.
No. So what we do is we do DFS from 3 now. Okay. And when we do DFS from 3, you know that 3 will get marked, 4 will get marked, 6 will get marked. Now this component is done. Clear?
Yes.
Yeah.
We'll go to 4. 4
Yeah.
is already visited. 5 is already visited. 6 is already visited. So whichever as soon as we find a node which is not visited, let's do it a DFS and visit all the nodes in that component. That's what we do. Chalo. So shall we go to code?
Yes, bro.
Okay.
Yeah.
So, it gonna be connected one or normal?
Sorry.
It will be disconnected, but we'll be like iterating the nodes.
Okay. So maybe Sas, we can see the code and get it more perfectly. Okay. Like
Yeah. Okay.
so, we'll create a folder for now. What's that? Graphs. Can we close it somehow? Okay. Now, what we are doing today is we are doing on undirected graphs only. Okay, and it's again same as directed. I mean, you can apply the same algorithm on directed also. Okay, so let's write. I mean, let's do the initial stuff. I don't know why it doesn't come. So, how many of you guys know that from the newer version, main is removed?
That's Java 21, right?
Is it?
Is it?
Yeah, it's from Java 21, I guess. 21, 22, 21,
No
21.
main method.
Yeah, main
Mm.
method has been removed.
Then how starting of the function, like where it?
Normal Python Laga.
Def.
Okay, okay. Let's focus on this. Duplicate modifier for the method main in type basis. Why, man? I somehow don't feel good with this sometimes. Okay, so what information we need? We need number of nodes, right? Correct. We also need something as number of edges. Correct. So how many of the edges? Maybe I can write it as edges. Now, same. How to store a graph? We need to store it, right? So which data
Yeah.
structure we will use? Manan,
Array list.
which one shall we use?
List.
List of ट्री पे क्या यूज करे थे हम लोग
Mm.
adjacency list. अरे भाई तुम लोग सब भूल गए तो कैसा भाई? You don't remember
Yes, bro. List.
zero
Yes, sir.
Yeah.
represented with
01, हाँ.
uh,
0110. हाँ.
ठीक है. Okay. Okay. Quickly, I'm just writing this. Okay. And we need one more information, which is Boolean visited, right?
Yes. Yeah.
Okay. Now we will read number of nodes in our graph. We will read number of edges in our graph, and what we will do, we will initialize our array list, that is adjacency one. Correct. And we also have to make this change also. Now why it is error? Because we have to make it static. Cool. Now what we'll do, we will read the edges information. Okay, so for an edge I will read two nodes, right? Which are the two nodes which are having that edge? Now what I need to do, I will go to u and add v, because
V.
u is having an edge with v. I will go to v and I will add an edge with
Add
v.
you.
Okay, so that my graph is ready. Clear?
Yes.
Yeah.
Okay, next. What we will do is, now our task is to explore or use DFS and kind of do something. Okay, so for int node equals to 0, node less than n, node plus plus. Okay, now see this technique, and it will be used everywhere. Okay, if my node is not visited, then only do a DFS. Okay, what I just explained right in the whiteboard, that whenever if it is not visited, start DFS. Okay,
Yes.
now
Yes.
we'll write a DFS method. So we will have a node, right? So first thing first, what we need to do, you remember? Can I, should I have to do
True.
that
Yes.
this node has
Yes.
been visited? Okay, and for our purpose, maybe we can try to print and see what is this node. Okay, and then what, once we have visited this node, what we will try to do is, we will try to explore all the other edges, integer, neighbors, same as tree. Okay, same as tree. If your neighbor is not visited, if your neighbor is not visited, please go ahead and do a DFS so that you will visit your neighbor also. Okay, clear? Straightforward as tree.
Yeah.
Nothing,
Yeah.
Yes.
nothing fancy. Chalo. So this,
Yeah. Yeah.
that's all. Okay, let me run this program and let's see whether we are able to do something or not. So let's take this graph. Okay, how many nodes we have? 1, 2, 3, 4, 7 nodes. 7 nodes. How many edges? Let's say there is one more. Let's add this also. Okay, so how many edges? 1, 2, 3, 4, 5, 6. 6 edges, right?
Yeah.
1,
Yeah.
2,
6.
3, 4, 5, 6, 7 edges totally. Okay, so there are totally 7 edges. Okay, so what are, 0 is connected with 1, 0 is connected with 2, 0 is connected with 5. First thing, 0 is connected with 1, 0 is connected with 2, 0 is connected with 5, right? Next, 1 is connected with 2, 2 is connected with 5. 1 is connected with 2, 2 is connected with 5. Okay, 4 is connected with 3, 3 is connected with 6. 4 is connected with 3, 3 is null pointer आ गया भाई. Okay, why null pointer? I just got to know. Can you guys tell me why null pointer? देखो what's the problem? "25th line it seems. Why this is a problem?
Visited array.
Yeah, visited array has not been initialized.
Initialized.
Okay. Right. Right. So see, we got this order 0, 1, 2, 5, 3, 4, 6. Okay.
Yeah.
0, 1, 1 say you will go to 2, 2 say you will go to 5. Okay. Now you would have started from 3 because you see, right, we have this if check that if it is not visited, then only do a DFS. Okay. So 0, 1, 2 has already been visited. But what about 3? 3 is present in separate component, right? So
Yeah.
3 will do DFS, will visit 4, will visit 6. And you see that's the order. Is there,
Got it, bro.
is there any chance that we can get 6, 4 also here? Or only we should get 4, 6?
No, we can get.
Sure? Manan,
Yeah.
is there a chance that we can get 6, 4? Or only 4, 6 will come?
Can get, I guess.
Sorry?
You can get, I guess.
Yeah, so we can get it, right? Because recursion is not in our hands, correct?
Mm.
Order might change.
Exactly.
Order might
Okay.
change.
So DFS clear, eh?
Yes, sir.
Yeah.
Yeah.
So let's take a small problem, okay, and maybe we can wrap it up today. Okay.
Bro, like we are having other example, right? Can you scroll down?
Okay.
And that in that notepad itself.
Notepad where, man? Other.
Like here we went to 4 and again we came back to 5, right? As it is also even visited. Will that cover this?
Which one?
Can
In
can you
this.
scroll? Not this, like above example. First example. Yeah.
Okay.
We are going to 5. Again we are going to 4.
Mm-hmm.
Again we are coming to 5. By that time it's visited, right?
Yes. So you are coming back to 5 means recursion is coming back. Okay. You are not
Yeah.
like not you. Like after 5 is 5 will explore 4. From 4 you cannot go back. Okay. So recursion will come back and it will again try to explore what are the other nodes which are there.
By that time 5 is already visited, right?
Yeah.
Yeah. Can you run that example and show us?
Okay. Probably that is better. What, Sam? We are confused with recursion then in that case. You have done dynamic programming and you are confused with this. 0, 1, 1, 2. See, how many nodes? 1, 2, 3, 4? 7 nodes. Okay.
Yes, yes.
So quickly, let's try to, someone just remember the sequence 0, 1, 1, 2. Array bhai.
Yeah,
Example
bro.
take na.
Yes.
7, comma, how many edges? 1, 2, 3, 4, 5, 6, 7. 7 edges.
Yeah, 7.
Okay. So 0, 1. Sam, 0, 1, 1, 2, 2, 3.
1 2. Yeah.
1, 3.
And 1,
1
3
3.
also. Next.
Yeah. 3 5.
Remember
3 5.
5, 5, 4, 5, 6. Okay.
Mm.
Yeah.
3, 5, 5, 4, 5,
5
6.
6.
Okay. Did we get this?
Okay.
What's happening, Sam, is as soon as you come to 5, this one will be true, right? Visited of 5 equals to true, correct?
Yeah.
Then we will go to neighbors. Let's say neighbor is 4. Neighbor is 4. Okay. Is your
Okay.
4 visited? No.
No.
So you will go to DFS of 4. Correct?
Okay. Okay. Yeah. Got it, bro.
Yeah. So again, after that, it happens. Again, you are starting from here only, right? That 4 has been done. Now you are iterating on 6. So 6 is also not visited. So go to 6. Clear?
Okay.
Clear, right?
Yeah, clear.
Sure. I mean, it should not be any problem because going forward, we don't want to fall into this trap again. Okay. Yeah. So others, are you guys clear on DFS part?
Yeah.
Yes,
Yeah,
bro.
bro.
Yes.
Okay. So do you want to do one problem? Or shall we stop it up? Whatever you guys.
We can stop.
Bus try na.